In this video, we're going to be talking about how to find the domain of a composite function. So here's the thing. The domain of a composite function f of g of x is in the set of the set of those inputs x in the domain of G for which g of x is in the domain of f. In other words, not only we have to make sure that x is in the domain of G and exclude from the domain of the x values that G cannot compute, but also notice that G becomes the input for f. So the outputs of G become input for f. So we have to make sure that the outputs of G are also acceptable input values for function f. So how do we do that? And here's the breakdown. Step 1, we are going to find the domain of G. Step 2, find the domain of f. And then step 3, find those input x in the domain of G for which g of x is in the domain of f. That is, exclude those inputs x from the domain of G for which g of x is not in the domain of f. The resulting set is the domain of G, f of G. Okay, so let's practice. Let's see how that looks in life, in algebra life. Okay, so we need to find the the domain of f of g of x. Okay, so g is the input in function f. Okay, so first of all, we need to find the domain of G, right? So this is our first step, domain of G. Well, G is a rational function, and the only restriction on x it has is that x should not equal to 0, right? Not x, the denominator should not equal to 0. So 3x minus 2 should not equal to 0. When we solve this inequality, we add 2 to both sides, and we have 3x is not equal to 2, so x is not equal to 2/3. So the domain of G is all of the x values except when x equals 2/3. Okay, now what's the domain of f2? So the domain of f is also a rational function, so we have to make sure that the denominator is not 0. So x minus 1 should not be equal to 0. And that means that x should not be equal to 1. Okay, but remember that the inputs of f are not x values, they're actually the function g. So for step 3, which reads find those inputs x in the domain of G for which g of x is in the domain of f. Okay, so we're going to plug in, instead of x, we're going to plug in our g function. Okay, so 4 divided by 3x minus 2, that's our x. We replace it with a g function, should not be equal to 1. Okay, so how we're gonna solve this inequality? Well, I will multiply both numerator and the denominator by, I mean, not numerator, denominator, sorry, the left and right side of the equation. by 3x minus 2. I'm gonna assume that 3x minus 2 is not 0, making sure I'm not multiplying both sides by 0. And actually, this right here ensures that, okay? So this is still working here. Okay, so the denominator get canceled out, so we have 4 is not equal to 3x minus 2, and then adding 2 to both sides, we have that x is not equal to 2. Okay, so now so these are those x's that when we put into g will give us 1 for the value of function g, so that we cannot put it into function f because it's going to turn f render it undefined. Okay, so now we're going to combine both of these. So our domain should not include 2/3, and it should not include 2. So what does domain look like? Domain is from negative infinity to, I think, so this one is smaller, 2/3. So 2/3, not including, and then from 2/3 to 2, and then from 2 to infinity. Okay, so this is how you figure out domain for that composition. All right, next, let's take a look at radical functions. Those are another type of functions where we have restrictions on the domain of so we have f of x is square root of x plus 2, g of x is square root of x minus 3. Okay. Now, again, we're looking for the domain of f of g of x. So step 1, find the domain of g. So the expression under the radical should be non-negative, right? So we want 3 minus x to be greater or equal to 0. Equal to 0 is okay. Oh, yeah. So that will give us negative x is greater or equal to negative 3. And then multiplying both sides by -1. Just as a reminder, your sign switches in that when you multiply by a negative number. So x is less or equal to positive 3, and that's our domain of g. Domain of g. Okay. Now, next, we want to find a domain of f. So again, for the domain of f, we want the expression under the square root to be non-negative. So x plus 2 is greater or equal to 0, and that gives us x is greater or equal to -2. Okay, so now let's put our function g in for x in here. So we're gonna have, so substituting x with a g, we have square root of 3 minus x is greater or equal to -2. When does it happen for each x values? Well, always, because the square root is always positive, always positive. always positive. So it's always greater than -2. So there are no actually x values that would render a value less than -2. So we don't have to worry about that. But notice inside here, we also expect a non-negative number, which is already taken care of, right? So by this inequality, x minus 3 greater than 0. So, for F, it doesn't have any restrictions, but G does. So our final answer, domain, is x should be less or equal to 3. So from -infinity to 3, including 3. And that's the answer for this problem. Now I want you to try this problem by yourself. And again, we need to find the domain of f of g of x. And f of x is a rational function, 1 over x minus 2. And g is a radical function. It's square root of x plus 4. So go ahead and use this 3-step process to find the domain of f of g of x.